At the end of this video, you should be able to list three observations that suggest that a chemical At the end of this video, you should be able to list three observations that suggest that a chemical reaction has taken place, and list three requirements for a correctly written chemical equation. A chemical reaction is a process by which one or more substances are changed into one or more different substances. In any chemical reaction, the original substances are known as the reactants, and the resulting substances are known as the products. According to the law of conservation of mass, the total mass of reactants must equal the total mass of products for any given chemical reaction. Chemical reactions are described by chemical equations. A chemical equation represents, with symbols and formulas, the identities and relative amounts of the reactants and products in a chemical reaction. For example, the following chemical equation shows that the reactant ammonium dichromate yields the products nitrogen, chromium 3 oxide, and water.
Chemical equations are a way to describe chemical reactions using symbols. The materials undergoing the chemical reaction are the reactants. The materials created by the chemical reaction are the products. Individual atoms and molecules in the reaction are separated by plus signs. The relative amount of each reactant or product is shown in front of the symbol for that substance. Symbols in parentheses after the reactant or product show the form of that substance, solid, liquid, or gas. AQ stands for aqueous and indicates that the substance is dissolved in water. Products and reactants are separated by an arrow indicating the direction of the reaction. If arrows point in both directions, the reaction is reversible. The products of this reaction can undergo another reaction that turns them back into the starting materials. If something is required to make the reaction progress, such as heat, pressure, or a catalyst, it is shown over or under the arrow.
To know for certain that a chemical reaction has taken place requires evidence that one or more substances have undergone a change in identity. Absolute proof of such a change can be provided only by chemical analysis of the products. However, certain easily observed changes usually indicate that a chemical reaction has occurred. First indicator of a chemical reaction: evolution of heat and light. A change in matter that releases energy as both heat and light is strong evidence that a chemical reaction has taken place. For example, you can see in the figure on the screen here that the decomposition of ammonium dichromate is accompanied by the evolution of much heat and light. And you can see evidence that a chemical reaction occurs between natural gas and oxygen if you burn gas for cooking at your house or camping. Some reactions release only heat or only light, but the evolution of heat or light by itself is not necessarily a sign of chemical change, because many physical changes also release either heat or light. Second indicator of a chemical reaction: production of gas. The evolution of gas bubbles when two substances are mixed is often evidence of a chemical reaction. For example, bubbles of carbon dioxide gas form immediately when baking soda is mixed with vinegar in a vigorous reaction that is represented on the screen here in part A on the left side of your screen. Third indicator of a chemical reaction: formation of a precipitate. Many chemical reactions take place between substances that are dissolved in fluids. If a solid appears after two solutions are mixed, a reaction has likely occurred. A solid that is produced as a result of a chemical reaction in solution and that separates from the solution is known as a precipitate. A precipitate forming reaction is shown on the screen here in part B on the right side of your screen. Fourth indicator of a chemical reaction: color change. A change in color is often an indication of a chemical reaction.
Sometimes, a chemical reaction will make gas. If this occurs in a liquid, you might see bubbles. For example, when we add vinegar, an acid, to a solution of baking soda, which is a base, a lot of fizzing occurs because carbon dioxide is released.
A properly written chemical equation can summarize any chemical change. The following requirements will aid you in writing and reading chemical equations correctly. The equation must represent known facts, meaning all reactants and products must be identified either through chemical analysis in the laboratory or from sources that give the results of the experiments. Also, the equation must contain the correct formulas for the reactants and products. Remember what you learned in Chapter 7 about symbols and formulas. Knowledge of the common oxidation states of the elements and of methods for writing formulas will help you, but are not necessary to supply formulas for reactants and products if they are not available. Notice that the elements in the table on the screen here exist primarily as diatomic molecules, such as H2 or O2. Each of these elements is represented in an equation by its molecular formula. Other elements in the elemental state are usually represented simply by their atomic symbols. For example, iron is represented as Fe, and carbon is represented as C. The symbols are not given any subscripts because the elements do not form definite molecular structures. Two exceptions to this rule are sulfur, which is usually written S8, and phosphorus, which is usually written P4. In these cases, the formulas reflect each element's unique atomic arrangement in its natural state. And lastly, the law of conservation of mass must be satisfied. Atoms are neither created nor destroyed in ordinary chemical reactions. Therefore, the same number of atoms of each element must appear on each side of a correct chemical equation. To equalize numbers of atoms, coefficients are added where necessary. A coefficient is a small whole number that appears in front of a formula in a chemical equation. Placing a coefficient in front of a formula specifies the relative number of moles of the substance. If no coefficient is written, the coefficient is assumed to be 1. At this point, you should be able to list 3 observations that suggest that a chemical reaction has taken place and list 3 requirements for a correctly written chemical equation.